I got this thing buzzing back here in my ear, that dehumidifier, so it's hard to hear. It's just quick review. We have a transversal. We got two parallel lines. Remember what our theorem said. Our theorem started off with this. It said if, everybody with me now? 100% attention, right? Okay. It says if you have parallel lines, then all these other things are true. What other things would be true? We said the corresponding angles are equal. And then what's some other things? The alternate, we didn't talk about slope when we talked about this. The alternate interior angles are what? Equal. What else did we say? Alternate exterior angles are equal, remember that? And then we also said what? That the consecutive interior angles aren't equal, but what are they? That's right. Very good. They're supplementary. Okay? Consecutive interior. Sorry, handwriting's a little sloppy. Haven't done this for a weekend, so got to get used to it again. All right, so parallel lines. But look at what this started off with. Every one of these said, if you have parallel lines. Follow me? Not just any old lines. If you have parallel lines, then all these other things are true. Today's lesson is very, very similar to what we just did, except they don't start off saying that we have parallel lines. All right, what they do is this. Let me try to get rid of this little arrow. Okay. What they do, and let me get rid of all these things right here. Oops, don't want to get rid of that line. Okay, good. Now this one, what's true about these lines right here? Do you know they're parallel? No, you have no idea, do you? So they're just two lines. It doesn't say, this equation doesn't say, or this formula I should say, or theorem, doesn't say if two parallel lines are cut by a transversal. This theorem says if two what? Lines. Why do I forget the I in there? I don't know why. If two lines are cut by a transversal, we'll just say, are cut by a transversal. And, watch this. This is the difference. It doesn't say that they're parallel right now. It just says if any two lines are cut by a transversal, and, watch, the corresponding angles are equal. That's not the if part, is it? This is all what? I should say it's not the then part. This is all the if part right here. If two lines are cut by a transversal and the corresponding angles are equal. Let's put some corresponding angles in here. Let's say 1 and 2. Are 1 and 2 corresponding angles? Yeah. Now, if they're equal to each other, which means we have to be told that they're equal in the first place, all right? If I was going to look at this, they might say something like this. You'll see this every once in a while. You'll see a given, and sometimes they'll say this, angle 1 equals angle 2. If they tell you that right there, then what can you do to this picture? Put a little what? Little arc, okay, here, and a little what? Arc right there. So it says, if two lines are cut by a transversal and the corresponding angles are equal to each other, what do you think the then part's going to talk about? Then the what? Say it. I heard it. The two lines are parallel, okay? Watch. If the angles are equal to each other, then guess what? Then the lines are what? Are parallel. I shorthanded a little bit in here, but that's basically what it says. If two lines are cut by a transversal, remember, this time it's different than what we did before. The if and the then switch, all right? Before it said, if two parallel lines are cut by a transversal. You follow me? So look, this then part says if you have two parallel lines. So we switch the if and the then. If two lines are cut by a transversal and the corresponding angles are equal, that's all part of the if. If all this is true, if you have two lines, they're cut by a transversal, and the corresponding angles are equal, guess what you can say about these two lines? You can now say that they're parallel to each other. Okay, we didn't know they were parallel to begin with, did we? Okay, they might have looked like it, but we didn't know for sure. All we knew is that these corresponding angles were equal. This theorem right here, actually this is a postulate as well. Remember, a postulate is what? Do you prove a postulate? You just accept it, right. What do you prove? What word do you prove? Theorems, right. We prove theorems, but we don't prove postulates. Okay, postulates are just things that are accepted. So this postulate says if you have two lines and it's cut by a transversal and you look at it and you see that the corresponding angles are equal to each other, we have that situation right here, don't we? Then what can you conclude? Then you can conclude that the lines are parallel. It's going to be very, very similar to what we did in the other lesson when we did parallel lines cut by transversal, except they're going to tell you that these angles are equal, and we have to determine which lines are parallel to each other. That gets a little bit more confusing, not a whole lot, but it's a little bit more, okay? But you got to understand the subtlety of the difference between these two. The if and the then are different. The first time we did this, we said if the lines are parallel, then the corresponding angles are equal. This one says if the corresponding angles are equal, then what? The lines are parallel. Do you see the difference between it? Okay, at first we didn't know these lines were parallel, but we did know the angles were equal. Then we can determine, hey, guess what? The lines must be parallel then. All right, that's the new one. These are called converses. I don't know if we talked about this. We've talked about if and then. So if you say if something, then something, we do this. I don't know, maybe some of you have seen it, maybe you've taken this at a different school or something like that, but we use the letters P and Q to represent if and then. The P represents if something, the Q represents then something. All right? They call this the, if I remember, I forget all my words, it's the hypothesis. They call this the hypothesis, and they call this the conclusion. Okay? So if this is true, then something else is true. This is our statement. But what did we do to that statement? We switched it around. We switched around the if P then Q. So how do you think we rewrote it? If what? If Q, then what?
P.
Then P. That's what we did. We switched it around. Guess what this is called? This is called the converse. All right, and we're going to refer to this every so often. Okay, we're going to see this quite a bit throughout geometry. You're going to see them give you a theorem. It'll say, if this is true, then this is true. All right? And then guess what? The very next theorem after it, they're going to switch it around. They're going to switch around the P and the Q, and they're going to say, if Q, then P. For instance, this one. This is a great example. The first statement was, if you have parallel lines, then the corresponding angles are equal. What's the converse of that? If you have corresponding lines, then the lines are parallel. You follow me? So watch. Our statement was, if you have parallel lines, then what? The corresponding angles are equal. What do you think the converse of that statement is? If what? That's right. If the corresponding angles are equal, then, that's right, then you have parallel lines. Make sense? Sorry about my writing. All right, so then you have parallel lines. That's the difference between a statement and its converse. We do that a lot. All throughout the book, we're going to do that. We're going to give you a theorem, and then it's an if-then statement. You with me? You're like all over the place. Sit still. Sit still and pay attention. You don't have to put your pencil down. It'd be good if you had your pencil in your hand ready to take some notes. Okay? There you go. That's better. If you have parallel lines, then the corresponding angles are equal. That's our statement. You flip it around. If you have corresponding angles are equal, if the corresponding angles are equal, then you have parallel lines. That's the difference between a statement and its converse. All right, we're going to do that a few more times. I'll tell you what, without even writing much more down, let's put some other, let's do this. Let's put a 3 and a, let's just put a 3 right there. What if we were told this? What if we were given, and a lot of times they'll tell you this, they'll either say given or they'll draw it on the picture or something like that. But why did I put another angle? So what if we said, given that angle 3 was equal to angle 2, what can we conclude? If I know, now I don't know these lines are parallel. Let me just erase these arrows just so you don't get confused. I don't know these lines are parallel. They're just any old two lines. So if these two lines are sitting right here, cut by this transversal, and if I know that 3 and 2 are equal to each other, then what can I say about these two lines? Let's call this line L and let's call this line M. So if this is true, if 3 and 2 are equal to each other, what's the relationship between 3 and 2? We talked about this a few lessons ago. There's a name. Alternate interior angles, okay? So they're alternate interior angles. Do you remember the first initial statement in the other lesson that we did? If you have parallel lines, then guess what's true about the alternate interior angles? Then they're equal. Guess what this says? If the alternate interior angles are equal, the lines are parallel. They're not equal. The lines are parallel. Okay, so then the lines are parallel. So if this is true, if you're given that angle 3 is equal to angle 2, then guess what you can say?
Line L is parallel.
Very good. Line L is parallel to line M. Exactly. You got it. Making sense to you? That's all this lesson is. All right, it's just taking them and just flipping them. That's all it is. So you already know about alternate interior angles. You already know about corresponding angles and alternate exterior and consecutive interior. You know all about that stuff, okay? Now all we're doing is flipping it around and saying, okay, if all that stuff is true, then the lines are parallel. That's all this lesson is. Let's do another one. What if I said, let's put 4. What if I said that angle 2 plus angle 4 equals 180 degrees? If you're given that that was true. What does that mean is true about 2 and 4 then? If they add up to be 180, guess what? They're supplementary. So if you have supplementary angles, if the consecutive interior angles, right, 2 and 4, if the consecutive interior angles are supplementary, guess what? What must be true about L and M? If the consecutive interior angles, 4 and 2, they're consecutive interior angles, if they're supplementary, which they told you they were basically, right, then what must be true about L and M? Then L must be what? Parallel to M. All right? That's the kind of stuff that they're going to do. All right? They're going to give you, and they might even say the word prove in there. Let me see. Yeah, they'll say, you know, is it possible to prove? Or it'll say, state the postulate or theorem that justifies your answer, things like that. All right, let's see what else I want to say. That's about it. I think that's good enough for you to be able to do this stuff. So what we're going to do is we're going to do page 209. So obviously it's lesson 3.5. It's page 209, and we are doing 8 through 21. Doing them all. Odds and evens, doing them all, okay? 8 to 21. Now what they're going to do is they're going to give you some pictures, and they're going to tell you some angles that are equal to each other. And you have to determine which lines are then parallel because those angles are equal to each other. Does that make sense? It's going to get a little more complicated than what we taught today, so be ready for it. It's not going to be quite this simple where they're going to give you one picture, one set of angles, and say, you know, what lines are parallel. They're going to give you several different lines, several different transversals. You're going to have to be able to look at it and determine, okay, if 1 and 2 are equal, these are my 2 lines, this is my transversal, so L must be parallel to M. And you got to look at it and decide which ones are parallel. All right? On your lesson, when you do this, call this part A. So call this section 3.5 and put an A right there because we're going to do a second part of it tomorrow. All right? So call it 3.5A. Is that all right? So you could jot that down right now, couldn't you? All right, that's it. So that's your homework. Have that ready for tomorrow.